Hi there, in this video we're going to go over sections 2.3 and 3.1. So we're going to explore some data and the measures of center, and we are also going to learn how to use StatCrunch. And I will go over one of the homework problems from my math lab so that you know how to take that data from my math lab and put it in StatCrunch. All right, so we're going to consider the data set from our textbook called Airport Data Speeds in Appendix B. And we're going to try to find the mean of these 5 speeds, all in megabits per second. So what is the mean? The mean, or arithmetic mean, of a set of data is the measure of center found by adding all of the data values and dividing the total by the number of data values. Oftentimes this is called the average, but just know that in statistics and any statistical analysis and study of data, we always refer to it as the mean. So let's look at what the notation is. And some things we talk about a statistic being resistant if the presence of extreme values or outliers does not cause it to change very much. Is the mean resistant? So if you have, do the data values affect the mean? Yes, right. The higher the data value, if you have high data values compared to everything else, that's going to inflate the mean. It's going to make the mean be higher. And so that means that the statistic is not resistant. Some notations that we're going to need in this class are notation for the sample mean and then the population mean. So the sample mean is x bar and is the mean of a set of sample values. And it is the sum, so sigma means the sum of all x's, where x are the data values, and divided by n. N represents the number of data values in the entire sample. Mu, that's the population mean, is the mean of all values in the population and is the sum of all the data values in the population divided by the number in the population. So when you think about the population, like if we wanted to do something for the entire United States, we will look at the census because that gives us the data for the entire population. And so we would look at mu. If we're dealing with quantitative data, we will find the mean on something like that. And then if we're looking at a subset of the US population, like say the state of California, people in the state of California, we are a subset of the US, but then that would be a sample. So we're a sample of the larger population being the United States. And so we would use X bar if we were checking the same variable, but mu is the mean of the population, X bar is the mean of the sample. So for our particular example, let's find the mean for those 5 speeds. So the data speeds from Verizon, and there are these 38.5, 55.6, and they're all in megabits per second. So because we only have 5 and it's a subset of the larger data from Verizon, we're going to use X bar because this is a sample. And so we're going to start adding them up. So we will list all of them and divide by, since there are 5 of them, we're going to divide by 5. Right, so the values are 38.5, so I'm going to add that plus the next one, 55.6, plus 22.4, plus 14.1, and then lastly, plus the 5th one that was given, 23.1. And they were up in here, 38.5, 55.6, 22.4, 14.1, and 23.1. So we add all those up, and because there were 5 of them, we divide by 5. And on our scientific calculator, or whatever calculator you're using, so add all those up and divide by 5, and we end up getting 30.74. And so that becomes the mean. Now notice that we did have a very large value here of 55.6 compared to everything else. That one was slightly higher, so that made the mean be higher than it might normally be. Another measure of center is the median. So let me just talk about that real quick. So the median is the value in the middle of the data. So the middle value of a data set. And so in order to find the median, you have to kind of organize it first in order from smallest to largest. So our data set, I'm going to say it is, so from the smallest, so 14.1, comma, I'm not adding, right? And then the next one looks like 22.4, comma, 23.1, 38.5, and lastly 55.6. So because there are 5 of them in here, the median is going to be the middle number once the data is ordered. So then this is the median. So this is another measure of center. And notice how far the median and the mean are from one another, 23.1 versus 30.74. And that's because of this large value, 55.6. And so this is why we say that the mean is not resistant. And that's because the different values of the data set will change the value of the mean. But the median, if I change any of these values, as long as I have 5 of them, the median will stay the same. So the median is resistant. And another measure of center is the mode. The mode is the value in the data set that appears most often, which here they all only appear once. So this data set does not have a mode. Right. The other definition is the weighted mean. So weighted mean is when different data values, so different x's, are assigned different weights, and we can compute a weighted mean in this way. So x bar would be the sum of all the weights times the data value divided by the total weight. And so a good example of this is computing GPA or computing your grades at the end of the semester if you have categories that are weighted. So like quizzes, 20%, exams, 15% each, things like that. They have weights. So let's try this example. So in her first semester of college, a student took 5 courses. Her finals, along with the number of units for each course, were A, so those are the grades, and then the number of units. The grading system assigns quality points to letter grades. So this is how a GPA is computed. So compute her GPA after the first semester. So the thing here to try to figure out is what are the weights and then what are our x's, our data samples, or data values. So the data values are the grades, right? So then our x's, oops, sorry, not sure what happened there. So our data samples are the grades. So x is the grade that she got. And so that means that the weight is going to be the units. Right? The weight of each class is how many units it is. So x bar in the weighted mean is the sum of the weights times the data value. So if the data values are her grades, let's try to put it in a little chart to visualize it. So I'm going to have the weights and then the x's. So the weights are the units and the x's are the grades. So the units, she had, the first class was 3 units, the next class was 4 units, the next class was 3, then 3 and 1. And the grades that she got were A on that 3-unit class, A on that 4-unit class, a B in that 3-unit class, a C, and then an F. Okay, now we can't really say A times 3, right, because we're not going to get a number. And so that's where this part comes in. And A is 4, a B is 3, and so on. So then here I'm going to have this is really a 4, this is really a 4, B is a 3, C is 2, and then F is a 1. So when I say my x bar is the sum of the weights, so weight times x, divided by the sum of the weights, then I'm going to be doing Wx, so 3 times 4. So I'm going to have 3 times 4 plus, and then 4 times 4 plus 3 times 3 plus 3 times 2 plus 1 times 0 divided by, sorry, I didn't leave myself enough room here, the sum of all the weights. The weights are the number of units. So 3, 4, 3, 3, and 1. So that gives us, what's that, 14? And so we find this. And so we're going to have 3.07 once you add all those up. And so that means that her GPA after the first semester is 3.07. And so that's how a weighted mean works. Now notice that for this particular person, the fact that her grade in the 1 unit class was an F really helped to keep her GPA decent. Had that F been in a higher unit class, like in a 4 unit class, this really would have affected, right? Because then the F, right, if that was 4, that would have increased the number here on the bottom, the sum of the weight, but that 4 times 0 would have still been 0. So the numerator would have stayed the same, but now you're dividing by a larger number, which will make it a much smaller quantity altogether. So that's how a weighted mean works. And so now let's talk about the different shapes. So we're going to do our exploratory data analysis. So this is where we're going to learn to use StatCrunch. So I have given you here some directions on how to use StatCrunch for different graphs. So we're gonna, in this class, we're mainly gonna focus on dot plot, histogram, and the box plot. They really help us. The box plot is really useful in helping us find all kinds of good information. So what I want you to do is go to your StatCrunch, and we're gonna create a dot plot for the data set. So go to My Lab and Mastering via our Canvas course, and then you're going to click on StatCrunch from the left menu, and you're going to open StatCrunch, and then do data sets from your textbook. Now, I do want to emphasize that if you just go to StatCrunch website, you won't see data sets from your textbook. You have to access from Canvas first, My Math Lab, and then click on StatCrunch. And then we're going to scroll all the way to the bottom and find airport data speeds. So I'm going to go through it, and I encourage you to kind of pause the video as you see me do it and do it on your own in a new window. Okay, so when you're on our Canvas page, go to My Lab and Mastering, and once that loads, you're going to go to Open My Lab and Mastering. And here you have to make sure that you enable pop-ups, because if you don't have them enabled, the window won't open up. So open My Lab and Mastering, and it opens in a new window, and that should take you to our My Math Lab page. And then you will see here on the left menu, right underneath Gradebook, there is a tab that says StatCrunch. So click on that, and this brings up StatCrunch. And notice that that's the place I want you to click, data sets from your textbook. Don't go to StatCrunch website, because then that's gonna take you to the regular StatCrunch, but then you won't be able to access the textbook data anymore. So click on textbook data, and here's our data for our textbook. And so the one that I want you to use, so scroll all the way to the bottom and click on airport data speeds. And here it is. So once we have the data speeds open, we can start working on the data. So we have Verizon, Sprint, AT&T, and T-Mobile. Those are the 4 carriers, and the airport code. So this represents the speeds in megabits per second of each carrier as people use data at the different airports. And so we're going to look at what did I say? The dot plot for Verizon. So you're going to go to graph and then select the dot plot. So if you go there, dot plot, it opens up this new window, and you want to make sure that you select Verizon, select the column that you want to work with. So Verizon, and everything else, you don't have to do anything else here, and then just hit compute. And as you hit compute, the dot plot is right here. Now for the dot plot, as you make the window bigger, it creates it bigger as well. So here is our dot plot. So these are all the values in this data set. And so they've been organized by each little dot represents each data value. And so this is what it looks like. So now that in the last chapter or section, we talked about the shape of a graph. So we had normal, uniform, skewed left or skewed right. What do we think this is? It has a right tail, so I will say it's skewed right. And so this is our dot plot. So if you want, you can copy it. The nice thing about StatCrunch is that if you go to options here and click copy, you can then paste it into your notes document. So I'm just going to close it. And notice that as I closed it, now I have a little number there that says 1. And so I have 1 result. And so that's my dot plot for Verizon. So now let's try, what about a histogram? So let's go ahead and graph histogram. And we're going to do it again for Verizon. And notice that if I wanted to mark the mean, I could do that. So let me select mean there. And we are going to select some things here. So let me go back to the notes real quick. So our notes for the histogram said, under bins, enter the following. Start at 5 with a fixed width of 10. So we're going to start at 5 for the bins. The bins are our classes, so how many bars we're going to have. And so let's go back to StatCrunch. So I'm going to see here where it says bins. I'm going to start at 5. So just enter the number 5. And width, we're going to select 10. So this is going to give us then 5 bars and with a width of 10 for each. And if I wanted to mark, like I said, there's the mean. Let me mark the median as well. And then that's it. That's all you need to fill and then compute. And so here is the histogram for Verizon. And so notice that there's the mean and 17.598 for the entire data. When we did it in our previous example, we only had 5 data values, but here we have a lot more. So it looks like we have how many? 50. So this is where StatCrunch will come in handy, because imagine doing 50 values by hand, right? And that may be doable, but what if it was 100, 200, 1,000? You don't want to do those by hand. So this is where StatCrunch comes in handy. So the mean appears to be 17.598. And then if I hover over to the red line, the median is 13.9. And so this is why this graph is skewed right. Notice that we have some unusual observations here. Those are called the outliers. And so a good way to tell which way the skewedness is happening is to look at which side of the median is the mean. So here's the median, the red one, and the mean is to the right of the median. So that means that we're going to have a data set that's skewed right. If my mean was to the left of the median, we probably have a skewed left. So we will have a left tail. And if they were pretty close to each other, we likely have a symmetric or normal distribution. And so this is for Verizon. Now, if I wanted to do for all 4 carriers, in my notes I did say find it for all 4. So let's go to edit here, and Let's select all of them. So just shift and hold down and click, and it selects. Notice that now I have all four. If I keep everything else the same, number of bins 5, so that means 5 bars. The width is 10, and my markers. Then I can compute, and notice that I get Verizon again. But now notice that I have a little error here. So I can go, oh, there's Sprint, there is AT&T, and there's T-Mobile. Now our axes changed a little. Notice that T-Mobile only goes to 30, Sprint to 40, AT&T also to 40, and then Verizon goes to 80. So ideally, we will want to set our x-axis to be the same for all four if we actually wanted to compare all four. Right? We don't want our axes to be different when we're comparing two data sets. That's where the misuse of statistics comes in. All right, so this is how we use StatCrunch to create a histogram or to create a dot plot and other graphs. So let's go back to the notes and see what other graphs do we have. Oh, the other graphs, we're going to study our step plots, time series graph, and all these other ones. So let's go back over here to more measures of center. So here for the definitions, we kind of already talked about all of them, but I can say, what is the mean? The mean, we can just say, is a measure of center. What about the median? The median is the middle value of the data set. And so in order to find it, well, we'll fill that in as we go through. The mode is the value that appears most often. The value that appears the most. And how do we find it? For the mean, you add up all the data values and divide by the total. Divide by the total. The median, that's the one that is, you have to arrange them put them in order and then find the middle. So we can say, arrange in what kind of order will we say? We can say an increasing order, and then the median is the value in the middle. Now, a note here that if you have an even number of data values, then you won't have a middle, right? And so then what you do is you take the 2 in the middle and average those 2 out. So if you had 6 data values, you will take the 2 in the middle, add them together and divide by 2. So that's how you find the median when it's an even number. Now the mode, you find it by seeing the value that appears the most. So the one that repeats the most. So the same way in finding the median, right? You arrange them in increasing order, and then the ones that repeat, they'll be listed next to each other. And so that's how you will find the mode. The mean, when to use it? When you're looking for the center of the data, you want, when it's a large data set, and the average or the mean is the best way to describe the center of that data. The median, when you use it when you don't have a lot of outliers, right? Because when you have a lot of outliers is when you want to use the median. Like, for example, if I wanted to describe the home prices in Sacramento, I would want to use the median home price instead of the average home price, because the median gives me a better picture, because it takes away those perhaps large home prices that we may see that are not representative of most of Sacramento. So if you have some, like in the fabulous 40s, that neighborhood, right, you may have some over $1 million or $2 million homes. That's really gonna, if you look at the mean price, the average house price in Sacramento, those are really driving the average up. So we look at the median, the middle value. And that gives us a better sense of where home prices are, looking at the median rather than at the mean. So we're going to go back to StatCrunch and find the mean, median, mode, and any outliers for the 4 carriers. So let's go back to StatCrunch, and so in here, let me get rid of that. And what we're going to do is we're going to go to, on your menu, go to Stat, so next to Graph, go to Stat, and you're going to go to Summary Stats. If you go down from on your handout of notes a little further, you'll see these directions on there. So, and then we're going to go to Columns. And that same window will pop up where we choose our columns. So just going back to the notes real quick, notice here the instructions in this little box. You're going to go to Stat, Summary Stats, Columns. We're going to, under the statistics, we're going to Control plus click to select the statistics that we want StatCrunch to find, and then you click Compute. So we want to find, well, the shape, we already looked at that by looking at the different histograms. So we want the mean, median, and mode. The range, this is probably going to tell us like how far does the data go, what's the highest value, and then any outliers. So let's go back to StatCrunch. And so here we are. So let me close out of this again. So our data, there's the help, graph, stat. So that's where you want to be. So for statistic, and then we want summary statistics, and we want column. So we're going to pick Verizon, and we want the mean. And remember the instructions said press the control key, and I want the median. Notice that if I just click on median, my mean that I had there goes away. So let me go back. So mean. So I want this white box here to show the ones that I'm going to compute. So mean, and then median. So find your control key and press it and hold it down and then click median. So now notice I have median. I want the range as well. So control, click, and the mode. The mode is way at the bottom. So control, hold it down, click mode, and now I have my 4 statistics that I want, and then click compute. And so it gives us our statistics for Verizon. So the mean, which we had already seen from the histogram, 17.598. The median is 13.9. The range is 7. It says 77, but I believe the highest value is 77.8. And then it says multiple modes. So that means that there are more than just one value that repeats. So this has multiple modes. And so we can take these values and insert them in the table in your notes. So the mean, the median, the range, and this one has multiple modes. In order to see what those are, you will have to go through the data. And this has 50, so I don't really expect you to do that. It's better if it showed us what the mode was. So let's go back, so close this out, and do it again for the other carriers. So let's practice. So summary stats, columns. So now I'm going to go to Sprint and do the same thing. Mean, scroll down to find the median, control, median, and then the range and the mode. And compute. And here are our statistics for Sprint. So the mean is 3.71, the median is 1.6, the range is 30.2. Now remember, these are the megabits per second. These are the data speeds while you're waiting at the airport. So Sprint is not looking very good compared to Verizon, right? So let's recall the Verizon. Here we go. The summary stats for Verizon, and then we can compare them. So the average data speed for Verizon was 17.598 megabits per second, whereas Sprint is 3.71. So Sprint is looking very slow compared to Verizon, and the range 77. So the highest speed that a user of Verizon got was 77.8 megabits per second, whereas for Sprint, someone just got 30.2 megabits per second, and the mode was 0.3 megabits per second, so pretty slow compared to Verizon. So go ahead and on your own practice doing the same thing for AT&T and for T-Mobile. So going back to our notes, we'll continue. So do those on your own and fill in this chart for your notes. And then exploring more graphs. So we have dot plots. We already looked at that. The stem plot or stem and leaf plot. Now these are for quantitative time series. These are what you normally see for like what we saw most recently with COVID data, right? When you're looking over a period of time and the number of data values. So this is a time series graph. Bar graphs, Pareto charts, and pie charts are mostly for categorical data. So when the ones that we're going to be using the most are dot plots and histograms in the box plot. So as a person, if you are a researcher and you're collecting data and you're doing statistics, most likely you will be using a dot plot. If you want to now present data in a research paper or present it to the media or anything like that, then you might use a histogram. But in order to study and make all your analysis, you're using the dot plot, most likely. And for categorical data, or bar graphs. And then we still can use dot plots and then pie charts to present the data. So let's take a look at some of these. The stem and leaf plots are not that intuitive. So let's go to StatCrunch and I can show you what I mean by that. So for example, if I go to graph and I want a stem and leaf plot, and we're going to do it for Verizon, and just compute. So here's our stem plot. So as you can see, it's not that intuitive to see what the data looks like. Like where is the point 10.3 on this? And so what it's doing is actually taking the first digit. So this is your tens digits. So 10, 20s, 30s, 40s, 50s, and so on, and then doing the point after. And so that's what I was saying, that it's not that intuitive as some of the other ones. So it's not used as frequently, but it helps to at least identify the mode and things like that. It's not very good at identifying the mean or the median, but we can see the values that repeat. And so it can help us figure out the mode. Remember for Verizon that it said had multiple modes, and now we can see, oh, these values repeat quite often. So in that sense, it's useful, but we're going to stick more with dot plots and histograms. All right, I'm going to break up the video, so I'm going to record another video for the rest of the graphs.